Hey guys, welcome back. Hope you all are doing well. Today we are gonna see exploiting HTTP request smuggling to perform web cache deception. So this is again all about web cache discrepancies between the front-end server and the back-end server. In the previous video, we saw web cache poisoning through the HTTP request smuggling, and in this video we are gonna deal with web cache deception by exploiting HTTP request smuggling. So the lab description is saying this lab involves a front-end and back-end server, and the front-end server does not support chunked encoding. That means it's interpreting content length. The front-end server is caching static resource. This again we need to see. To solve the lab, perform a request smuggling attack such that the next user's request causes their API key to be saved in the cache. Then retrieve the victim's user's API key from the cache and submit it as the lab solution. So you will need to wait for 30 seconds for accessing the lab before attempting to trick the victim into caching their API key, and you can log into your own account using the following credential. The username is Wiener and the password is Peter. So without wasting time, let's just jump to the lab. This is our lab. Proxy is working. And what I'm gonna do is I'm going to see the web root request, which is this one, and I'm gonna send this request 2 times to the repeater and go to the repeater. Everything is pretty same as you did in the previous labs. So the first thing first, degrade the HTTP protocol version for both of these requests. So for this one also HTTP version 1. And here what I'm gonna do is change the request method to post, and then I'm gonna delete these all the headers, and I'm gonna add one more header, which is transfer encoding, and the value of it is gonna be chunked. Okay, so first of all we will see whether the server is vulnerable for the CLTE or not. So for that purpose, I put the transfer encoding chunk header, and then I'm gonna define here a chunk size which is 4, and the value of the chunk is gonna be 4 times A. Then I will put here an invalid chunk size which is M, because the chunk size is represented with the hexadecimal, and M is an invalid hexadecimal value. So that's pretty fine. If you want to enable the turn line feeds, you can do it by this, and then I'm just gonna send the request. Oh, okay, wait a moment, I forgot to turn off update content length automatically, so it actually updated the content length automatically. So just click on this and turn off update content length, and if we see this one, if we just highlight from the last day up to the 4, so you can see there are 7 bytes of data. So I'm gonna update it with the 7 bytes content length and then send the request again. So if the front-end server is interpreting the content length, it's gonna say communication timeout in the response, and as you can see, communication timeout. So this is perfectly fine. Now we need to see whether the backend server is interpreting transfer encoding or not, and for that purpose what I'm gonna do, put here 0. 0 means the message ends here, and then I'm gonna add here a new request starting with get / anything that does not exist HTTP /1.1, and then I'm gonna put here content length and transfer encoding. Content type and content length. So paste that here, and then I'm gonna put here some data. Let's say fake is equal to data. Okay, now the best thing is to update the parameters like content length and transfer encoding from the bottom. So I'm just gonna highlight the data here, fake is equal to data, and you can see there are 9 bytes of data. So I'm gonna put here 12, more than 9 bytes, and then because I want to send everything to the backend server, so I will just highlight everything from 0 up to the last, and you can see the content length is 109 bytes. Okay, so we can update it 109 bytes here, or you can just simply turn on the update content length fine, and just send the request. So 200 okay. Now send the normal request, 200 okay. Again send the HTTP request smuggling request, attack request, and again send the normal request. And as you can see here, not found because this endpoint slash anything does not exist. And as you can see, the content length is automatically updated to 109 bytes. Fine, so this confirms that CLT vulnerability exists. Now we need to find out a point where the front-end server is basically caching the responses. So if we go back to our labs, remember we have a valid credential. So I'm just gonna log in, and here you can see WIENER Wiener is the username and Peter is the password. Send the request, and you can see this is our API key. So we basically need to get this API key belongs to the victim. So we will actually cache the response somewhere, okay, in the front end, and then we will get the API key. So for that purpose, we need somewhere the caching mechanism. And for that purpose, just go back to the proxy and let's see any static resource, let's say tracking.js. So any static resource you see here, like tracking.js, you can see cache control response header is there, and maximum age is 30 seconds, age is 0, X cache is missing. So any static resource contain these headers. That means these static resources are coming from the cache, and front-end server has some caching mechanisms implemented. Fine. So we will just choose one static resource, and I'm gonna send this request to the repeater. Also, I want to send this request where I log in to the Wiener user, and I'm gonna send this request to the repeater also. So first thing first, about the static resource, this tracking.js, about the web cache. So if I send this, you can see in the response, cache control is there, age is 0, X cache is missing. I already recorded both of the vulnerabilities module, like web cache poisoning and web cache deception. You can go to the playlist, search for it, and you will have the in-depth knowledge about it. Now here I'm just not going to describe and explain everything, because I already did it. I will give you just a high level overview. Fine. So if I send the request, you can see this time the age is 30, maximum age is 30, and X cache hit. So if you see X cache missing, that means the response is not coming from the cache. Okay. And age is 0 because this was the very first request. Now if I send the request again, you can see age is 10 seconds, because once the first time when the user access the resources through the front-end server, the first time the response saved into the cache, and when the next time any user come to access the same resource, it is going to response it from the cache. Okay, so you will get here hit means the response is coming from the cache, and also up to now only 10 seconds are being passed, and it will only cache the specific response for 30 seconds. Now the thing here is, if we go back to our dashboard, and you can see here, if we scroll down in the response of the dashboard, you will find here API key, and this is our API key. So I'm gonna just search about it, so we will get it more easily. Now let's try to manipulate it a bit. So I'm gonna say Carlos. Let's see if I can get the Carlos API key or not. And you can see 302 found, and it's redirecting us to the login page. That means the sessions are bind with the session cookie. Okay, sessions are validated, so you cannot get it like this. Fine. But if we go back, and if we just delete this ID parameter or the query string and send the request one more time, and you can see there is one match for the API key. If I click on it, you can see this is our API key. So even even if you do not put here the query string, you will get the API key and the same response for the dashboard for the specific user from which you are logged in, because this session cookie is specifically allotted to your session. Okay. So what we want to do here is we want to somehow, whenever the user log in or from the my account page, whenever the user refresh its my account page, I want this response basically saved somewhere in the cache. Okay. And then we will get the response of this request through the cache, and we will successfully get the API key. Okay. And all of this thing we will do it through the HTTP request smuggling. Fine. So what we are going to do, we are going to delete everything from here, and here instead of anything, I'm gonna take the my account, this endpoint, Control C, and paste it into our attack request. Okay. And then I don't need here content length and content type or transfer encoding. I'm just gonna say X-ignore, and the value of X-ignore could be X, Y, Z, whatever you want. Fine. So what I'm gonna do here, this is the tracking.js, and I think because we did not access this request from few minutes, so when I send this request, it is gonna be the first request. Okay, so just see. Okay, this is the first request. I will wait until 27 seconds, and then we will send our attack request. Fine. Okay, 23, 24, 25, 27, and just send this attack request. Okay, 200. Okay, then go back to the my account page or go back to the tracking.js basically, and as you can see, this time we get 200 okay instead of this response where we get the image. Okay, so that means this is the my account request response which we see here, and if we try to search API key, so you can see this is the API key, and this API key belongs to the victim, because if I come back to our my account request, you can see our API key start with 6A and end with PZM, where this one start with IQ and end with WVAD. So this is the victim API key. So what basically happening here is when you send this request, this attack request, it is basically going to bring this my account whenever the victim user try to access the my account. Okay, it's gonna take this request and put it like this. Okay, fine. So that's it. I'm gonna take the API key from here and copy that back to our lab, submit solution, paste the API key. Okay, and we solve the lab. So that's it for this video. I hope you enjoy it. If you have any query, please put your query in the comment section. I will try to respond as soon as possible. If you like the content, please like, subscribe, and share. I'm going to see you in the next video. Bye.